In this video, we're looking at calculating basic probabilities. If you know what all the possible outcomes are, in other words, if you know every single possible thing that could happen, and they are all equally likely, no one of them is more likely than any of the others, and you know how many of those outcomes you count as a success. And when we say success, we just mean it meets the criteria we're interested in. It doesn't necessarily mean you've passed the exam. It just means it does what we're looking at. Then you can use that information to calculate the probability of success by using this formula. P success means the probability of this thing happening, success, is the number of possible outcomes that give us what we want, divided by the total number of possible outcomes. So here's an example. You're spinning this spinner, and we're going to look at the probability of it landing on 3 and of it landing on a prime number. Have a think about it, see if you can work out the answers, and then press play to go through them. The solution then. It's got 8 equally spaced sectors, so it could land on any number from 1 to 8, and all the sectors are the same size, so there are 8 equally likely outcomes, 1, 2, 3, 4, 5, 6, 7, or 8. There's only one of those outcomes that will give you a 3. So in the case of part A, our criterion for success is that it lands on 3. So there's only one way we can do that out of the 8 possible results. So the probability of landing on 3 is 1 out of 8, 1/8, or 0.125 or 12.5%. For B, what prime numbers have we got on here? We've got 2, 3, 5, and 7. Remember, 1 is not a prime number. So that's 1, 2, 3, 4 outcomes that would give us success. So the probability of getting a prime number is 4 out of the 8 possible outcomes, which you could cancel down to a half. But with probability questions, they're usually not bothered about you cancelling fractions down. Now have a go at these ones. We've got a bag with red and blue balls in it. We've got the letters of a word written on cards. And we've got a box of chocolates. So pause the video, work out your answers, and press play when you're ready to go through them. Okay, number 1 then. If we've got 3 red and 5 blue balls, then we've got 8 balls in total, and you're equally likely to pick any one of those. So the total number of possible outcomes is 8. For A, 5 of the possible outcomes are blue, so the probability of getting a blue ball is 5 out of the 8 possible outcomes, or 5/8. For B, the probability of getting either a red ball or a blue ball, well, for the blue it's 5/8, for the red it's 3/8, which of course adds up to 8/8, which is the same as 1. That means certain. Well, of course it's certain, because all the balls are either red or blue. There are no other options. So we say that the events ball is red and ball is blue are exhaustive. They cover all the possible outcomes between them. And of course, if they're all either red or blue, then the probability of getting a yellow ball is going to be 0. It's impossible. There isn't one. Number 2, how many possible outcomes do we have? How many cards are we going to have with letters on them? We've got 9 letters in the word, so we're going to have 9 cards, 9 possible outcomes. Now for A, 2 of those cards have S's on them. So the probability of getting a card with an S on it is 2 out of the 9 possible outcomes, 2/9. And for B, the probability of getting a card with a vowel on it, well, which vowels do we have? We've got the O, the I, and the E. So that's 3 out of the 9 cards that have vowels on them. So the probability of getting a vowel is 3/9, which you could simplify to 1/3, but as I say, there's no real need to simplify them in probability questions. For number 3, we've got it in table form this time. So we've got a box of chocolates, and it has 5 caramels, 4 fruit creams, and 6 truffles in it. That's all there is in the box. There are no other chocolates. So how many chocolates do we have in total? Because that's the number of possible outcomes. We've got 5 plus 4 plus 6 is 15 chocolates. So that's 15 possible outcomes. How many of those are truffles? 6 of them are truffles. So the probability of getting a truffle is 6/15. And the probability of getting either a caramel or a fruit cream is, we've got the 5/15 for a caramel and the 4/15 for a fruit cream. We add them together and we get 9/15. How about the probability of something not happening? Well, if the probability of a particular thing happening is P, then either it happens or it doesn't. There are no other possible outcomes. So the events it happens and it doesn't happen are exhaustive. Remember that word? They cover all the possibilities. So if we add the 2 probabilities of those things together, we're going to get 1. The probability that the event happens plus the probability that the same event doesn't happen must add up to 1, because it can't be anywhere in between happening and not happening. So the probability of the event not happening is 1 minus the probability of it happening, which is 1 minus that little p that we defined at the beginning of the page. Now, if you think back to the last question on the previous slide, 5 caramels, 4 fruit creams, 6 truffles. For part B, if it was a caramel or a fruit cream and you only had truffles, caramels and fruit creams, you could equally well have said not a truffle, because anything that isn't a truffle is either a caramel or a fruit cream. So instead of adding up the caramels and the fruit creams, we could have just taken away the number of truffles from 1. So 1 minus 6/15, that's 15/15 minus 6/15, which leaves 9/15. Here's one for you to have a go at. Pause the video, work out your answer and press play when you're ready to go through it. Okay, the answer. Well, we've got 3 red, 2 green and 5 blue counters. So in total, that's 3 plus 2 plus 5 is 10 possible outcomes. And the number of those possible outcomes that are green is 2. So the probability of getting green is 2 out of the 10 possible outcomes. So the probability of not getting green, well, we could add up the 3 for red and the 5 for blue, but if you had more than 3 colours, you'd have more work to do. The other thing we can do is just to take the 2/10 away from 1. So the probability of not green is 1 minus the probability of green. 1 is 10/10. We take away the 2/10 and we're left with 8/10 for our probability.